Today I will talk about Lewis dot structure, but firstly we have to mention some rules. The first rule is that we have to know the valence electron number for a molecule, and we can use a periodic table, and then we can make an electron configuration for each atoms to calculate the total number of valence electron in the molecule. And the second, we put the least electronegative atom in the center. And if you know the electronegativity increases periodic table from here to here, and the fluorine is the most electronegative atom, and these are the some electronegativity values for the elements. And then we put two electrons to form bonds among the atoms, and then we have to complete the octets, but there are some exceptions for that rule, and this is one of the common example is hydrogen. So it follows doublet rule due to it has only two electrons. And if the octet rule is not satisfied, try to make new bonds, and we can make double bond, triple bonds in some molecules, and then we can check the formal charge if there are more possible Lewis structures. At the valence, and we can check the formal charge, since the formal charge is equal to valence electron minus non-bonding electrons minus bonding electrons over 2. So you definitely have to know this formula. And we can start with the first example. So firstly, we have to know the number of total valence electrons. And then we should look at the periodic table if you don't memorize it. So here the periodic table. So nitrogen have 7 electrons. So its electron configuration 2 and 5. Hydrogen has 1 electron. And this is the configuration for the hydrogen. So how many electrons do we have? We have 5 electrons. That is due to the nitrogen plus. So we have 1 nitrogen and we have 5 electrons for the nitrogen. Plus we have 3 hydrogen, and each of them contains 1 valence electron, and total is 8. We need 8 electrons. And the second rule was to put least electronegative atom to the center, and I will put nitrogen here, and I put its electrons. One electron here, 1 electron here, 1 electron here, 1 electron here, and I have to put 5 electrons. So I want to put 1 more electron here. Then I need to place the hydrogen atoms, and I should put their electrons also. For each hydrogen I have to put 1 electron, since we have 1 electron for the hydrogen. Okay, so this is our Lewis structure, and if we look at the nitrogen atom, octet rule is satisfied, since we have 8 electrons for the nitrogen atom. On the other hand, for the hydrogen, we don't have the octet rule, so we have a doublet rule, and it's satisfied since each hydrogen atoms has 2 electrons. So this hydrogen has 2 electrons, this hydrogen 2 electrons, and this hydrogen has 2 electrons. So this is the correct Lewis structure, and some people prefer to use bonds instead of electrons, and I am one of them. I generally prefer to write a Lewis structure for a ammonia molecule, something like this. So bond represents 2 electrons. And we can also look at the borane. This is a borane molecule, and this molecule has octet rule exception. The reason is that borane has 3 valence electrons. If you look at the borane in the periodic table, so borane has 5 electrons. And we can write the valence electron configuration 2 and 5, no 2 and 3. So borane has 3 valence electron, and hydrogen has 1 electron. Total electron is 3 times 1. We have 1 borane and 3 electrons comes from the borane, and we have 3 hydrogen atoms, and each of them contains 1 electron. See, we have 6 electrons for the borane. I have to put the least electronegative atom to the center, and I will put 3 electrons for the borane. Then I will place the hydrogen atoms for the molecule. And hydrogen has 1 electrons, right? 1 electron for this hydrogen, 1 electron for this hydrogen, and 4 electron for this hydrogen. So in this case, this is the Lewis structure. And if you look at the borane, we don't have an octet rule here. We have 6 electrons for the borane atom, and each hydrogen has 2 electrons. And the total number of electrons for that molecule is 6. So we satisfied this rule. And we can continue to more complicated examples or harder one. H₂SO₄ is one of the harder molecule, I think. So therefore I choose it. And firstly we have to calculate the number of valence electrons for that molecule. We have 2 hydrogen atoms, and hydrogen have 1 valence electron. Sulfur has 6 electrons, and we have 4 oxygen, and each oxygen atom has 6 valence electrons. If you calculate it, 24 plus 6 plus 2, we have 32 electrons. And for the second rule, we have to put the least electronegative atom to the center. Okay, I put the sulfur to the center, and I have to put 6 electrons for the sulfur atom. And then I place the oxygen. One oxygen here, one oxygen here, another oxygen here, and another oxygen here. Okay, and we have 6 electrons for the oxygens. One, two, three, four, 5, 6. 1, 2, 3, 4, 5, 6. 1. And I want to create bonds between them. So each 2 electron causes a bond. So these are bonds actually, right? I want to write in this one. And we have hydrogens, and each hydrogen has 1 electron, and they can make bonds, of course. And this is the Lewis structure of H₂SO₄. We can look at the formal charge for this molecule, since it is complicated and sulfur does not follow the octet rule. As you see, it has more than 8 electrons. To look at the formal charge, we have to know the valence electrons. So maybe I should write the formula. Valence electrons minus non-bonding electrons minus bonded electrons over 2. So we have 6 valence electrons for the sulfur. Okay, the non-bonding electron number is 0 since all the electrons are bonded, and bonded electrons number 2, 4, 6, 8, 10, and 12. So 12 over 2. And the formal charge on the sulfur is 0. This is the formal charge formula. You should keep in mind that before a chemistry exam, definitely. And we can also calculate the formal charge on oxygen, for instance, for this oxygen. And valence electron number is 6 for oxygen. There are 4 non-bonding electrons, and there are 4 bonding electrons over 2, and it is equals to 0. So formal charge on this oxygen is 0. If we can look at this oxygen atom and to calculate the formal charge, and formal charge is equals to 6 electrons. It has 6 valence electron. Non-bonding electrons is 4, and we have 4 bonding electrons over 2, which means that the formal charge is equal to 0 for this oxygen also. So total formal charge is 0 for all the atoms. Therefore, this is the correct Lewis structure for the H₂SO₄. And we can make an example. HNO₃. This is a very strong acid. And first, I should calculate the valence electrons numbers. And we have 1 electron due to the hydrogen. We have 5 electrons due to nitrogen, and we have 1 nitrogen atom. And we have 6 electrons due to 3 oxygen atoms. And if you calculate that number, it will be 24 electrons. I will put the nitrogen to the center. Okay, 1 electron here, 1 electron here, 1 electron here, 1 electron here. So this is 4, and this is the 5th electron for the nitrogen atom. Then I will put the oxygen. I will put 1 oxygen here. 1, 2, 3, 4, 5, 6. And I put 1 oxygen here and the other oxygen here. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the issue is that I have to make bonds. So I can put this electron here to make 1 extra bond. Okay, so I put this electron here. So we need 24 electrons, so you have to keep in mind that. And I have no choice. I have to put a hydrogen here with 1 electron, since hydrogen have 1 electron. Then this electron can go here to make a single bond, and this electron can go here to make a single bond. And I will place the 2 electron in here, so it's something like this. Okay, and I will put the bonds instead of electrons. I prefer bonds. So 1 bond here, a double bond here, and another bond here. The question is that, is it stable? To understand that, we need to look at the formal charge. So if you look at the nitrogen, we have 5 valence electrons, and we have a bond here. Five minus non-bonding electron number is 0, minus bonding electrons over 2, so which is 1, 2, 3, and 4, 8/2, 4. So plus 1. Nitrogen has plus 1 oxidation state. And this oxygen is natural. We calculated in the sulfur case. And hydrogen has zero charge again, and oxygen here is also zero charge. What about oxygen? So we can calculate the formal charge for that oxygen. The valence electron is 6 for the oxygen. Non-bonding electron number is 6. We have 2 electrons that bonded and -1. Or -1 is the charge on that oxygen molecule. So total charge for that molecule is 0, and therefore this structure is a correct Lewis dot structure.